Hello everyone, I am your chemistry coach. Today what we are going to discuss, electrolysis of an aqueous solution. Previously I have uploaded few others video about electrolysis. Now we are going to discuss electrolysis of aqueous solution. What happened when we have an aqueous solution and which product will gonna appear at cathode and which product will gonna appear at anode. Now let's see about this topic. The topic name is electrolysis of aqueous solution. Just imagine we have an aqueous solution. For example, I have aqueous solution of sulfuric acid. This is aqueous solution of sulfuric acid. It means sulfuric acid is mixed with water. So when electrolysis of this aqueous solution of sulfuric acid will take place, then we have to figure out which product will appear at cathode and which product will appear at anode. Just imagine this is an electrolytic cell, and this electrolytic cell has one electrode here, and this electrolytic cell has one electrode here. And these two electrodes are connected with the battery. Battery has two terminals. One is positive terminal and other is negative terminal. The electrode, this one is the negative terminal. The electrode which is connected to the negative terminal of battery, we call that electrode as cathode. And the other electrode which is connected to the positive terminal of battery, we call that electrode as anode. As you know, as you see, anode is connected to positive terminal of battery, so anode carry positive charge. And you see cathode is connected to negative terminal of battery, so cathode carry negative charge. Now the situation is, in this aqueous solution, we have aqueous solution of sulfuric acid. It means, first of all, just try to understand how many ions or how different types of ions are there in solution. The solutions contain ions, positive and negative species. So, and this has a lot of water as well. This solution has aqueous solution of sulfuric acid, aqueous solution of sulfuric acid. It means we have ions from water as well. Aqueous means water. We have a lot of ions from water as well, and we have certain ions from sulfuric acid. So let me write ions from water. And water has weak dissociation power, but still water produces certain ions. The ions which I am getting from water is hydrogen ions, and you can say hydroxide ions. Aqueous, hydrogen ion aqueous and hydroxide ion aqueous. These two ions, hydrogen ion and hydroxide ions, will produced from water. Now ions from sulfuric acid, H2SO4. The ions which I get from sulfuric acid is hydrogen ions, all right. And you can say that the other ions which I get from sulfuric acid will be the sulfate ions. The point is, the ions which we obtain from water is hydrogen ion and hydroxide ions. The ion which we get from sulfuric acid is hydrogen ion and sulfate ion. So now we have to figure out which ions will migrate towards anode and which ions will migrate towards cathode. So at anode, you see Anode carry positive charge. So it means all those ions which are present in the solution which have negative charge, they will migrate, they will move towards anode. Such as in my solution, I have a lot of hydroxide ions and a lot of sulfate ions and a lot of hydrogen ions as well. I am getting hydrogen ions from water as well. I am getting hydrogen ions from sulfuric acid. I am getting hydroxide ion from water. I am getting sulfate ion. This is my sulfate ions, sulfate, and I am getting sulfate ions from sulfuric acid. So in my solution, I have a lot of hydrogen ions. I have a lot of hydroxide ion. I have a lot of sulfate ions. As you know, you see anode carry positive charge. So hydroxide ions also want to move towards anode, and sulfate ion also wants to move towards anode. Sulfate ion being a negative charge species, sulfate ion also try to reach towards anode, and hydroxide ion being a negative charge species, hydroxide ions also try to reach towards anode. The point is, now the point is, which ion will reach earlier at anode? The point is, which ion will reach earlier at anode? Both these ions, hydroxide ions and sulfate ions, both left to migrate towards anode because anode carry positive charge and these ions carry negative charge at that situation, at that moment. The point is, which ions reach anode earlier, whether hydroxide ion reach towards anode earlier, whether hydroxide ions will reach at anode earlier, or whether sulfate ion will reach at anode earlier. The ions which reach earlier at anode will discharge first, and the product will be formed according to that ion. Again, listen carefully what I am trying to explaining. You see in my solution a lot of hydroxide ion, a lot of sulfate ions. So towards when considering anode, hydroxide ion also want to move towards anode, and sulfate ion also want to move towards anode. The point is, which ion reach anode earlier? The point is, which ion reach anode earlier? The ions which reach at anode earlier will discharge first, and the product will be decided according to that ion which reach earlier at anode. For example, in this case, hydroxide ion, there is a race, there is a competition between hydroxide ion and sulfate ion. There is a competition, there is a race between hydroxide ion and sulfate ions to reach anode earlier. And which ion will reach anode earlier? The answer of these questions will be given in this series. You see, this is selective discharge list. And here cations are mentioned, and here anions are mentioned. You can understand this list as well. So you see in this list, I have arranged few cations and few anions, and this is selective discharge list. And difficulty of discharge decrease from top to bottom. Very important point. Difficulty of discharge decrease from top to bottom. What does this means? Difficulty of discharge decrease from top to bottom. What does this phrase means? What does this sentence means? Difficulty of discharge decrease from top to bottom. This means the ions which are present at the top will reach later. Oh, sorry. This is something wrong. Let me clarify this. The point is this is the difficulty of discharge decrease from top to bottom. This means the ions which are present at the bottom will reach earlier at electrode. The ions which are present at the bottom will reach at electrodes earlier, and the ions which are present at the top, that ions will not reach. The ions which are present at the bottom will reach at electrodes earlier and will discharge first. What does this term discharge means? Discharge means whether that ion will oxidize or whether that ion will reduce, whether that ion will get electron or whether that ion will donate electron. And now I have to decide between sulfate ions and other is hydroxide ions. I have to decide between these two ions that which ion reach at electrode earlier. You see, in the list, hydroxide ions is present at the bottom and sulfate ion is present at the top. And I have mentioned that the ions which are present at the bottom will reach at electrode earlier. So hydroxide ion will reach at electrode earlier. So it means when hydroxide ion reach electrode earlier, then hydroxide ion will discharge first. And how hydroxide ion will discharge? Hydroxide ion will reach at electrode earlier, and hydroxide ion will reach at anode earlier. Hydroxide ion carry negative charge at anode. Oxidation takes place, and remember, in case of sulfuric acid, I have to make this equation, to make this ionic equation balanced. I have to put 4 here. Then I will get two water molecule. 4 hydroxide ion will reach at anode. When 4 hydroxide ion will reach at anode, these 4 hydroxide ions will convert it into 2 water molecules and oxygen gas and 4 electrons. This is the balanced ionic equation. It means, remember, oxygen gas will be given off at anode. Oxygen gas will be given off at anode. So when the question is which product will produce at anode in case of aqueous, in case of electrolysis of aqueous solution of sulfuric acid. Again, listen. When the question is which product will appear at anode or which product will produce at anode when electrolysis of aqueous solution of sulfuric acid will take place, then remember oxygen gas will be given off at anode. Okay, you see from here, oxygen gas will be given off at anode. Sulfate ion will never be reached at anode because hydroxide ion already have approached towards anode, and hydroxide ions already reached at anode. Hydroxide ion already reached at anode. Hydroxide ion already discharged at anode. No, sulfate ion cannot reach at anode. And now in case of cathode, there is no competition because cathode carry negative charge, and in the solution only hydrogen ions are those ions which have positive charge. So these hydrogen ions will reach at anode, at cathode, and these hydrogen ions will convert into hydrogen atoms by getting an electron. Let me write these equations. By getting electron, this hydrogen ions converted into hydrogen atoms, and if I have just let me write, if I have one more hydrogen ion to make this equation balanced, then I have one more hydrogen atoms. These 2 hydrogen atoms combine together and hydrogen gas will be appear. So at cathode, hydrogen gas will be given off. At anode, oxygen gas will be given off in case of electrolysis of aqueous solution of sulfuric acid. So let me summarize these things by opening one of my book, guys, one of my good book. If you have any personal questions, you can contact me via WhatsApp number. I have mentioned all these details in the about section of this YouTube channel, Chemistry by Saad. Okay. So the topic is, from notes you can follow that books as well, and you can also follow the books which you guys have. The electrolysis of aqueous solution. Electrolysis can also be carried out on solution of ionic compounds in water, because the ions in the solution are free to move, but the result may be entirely different than for the molten compounds. Compare this. When I have chosen molten sodium chloride, the product at cathode is sodium and the product at anode is chlorine. But when I have chosen a concentrated solution of sodium chloride, it means this concentrated solution of sodium chloride, it means this solution has a little bit water as well. Then the product at cathode is now hydrogen gas, not sodium. And the product at anode is chlorine gas. Okay, this is again one thing tricky, and I will explain in my later on video. In my next certain video, I will try to explain what happened when I have chosen concentrated solution of sodium chloride, which product will gonna appear at cathode and which product will gonna appear at anode, and what is the story, what will be the story when I have chosen dilute solution of NaCl. In case of dilute solution of NaCl, which product will gonna appear at cathode and which product will gonna appear at anode. And in case of molten NaCl, in case of molten NaCl, it's very quite predictable and it's very easy to explain which product will appear at cathode and which product will appear at anode. In case of molten NaCl, sodium being a positive charge species will appear at cathode as sodium metal, and chloride ions being a negative charge species reach at anode and will appear at chlorine gas. But in case of concentrated NaCl and in case of dilute NaCl, the story is entirely different. I will discuss in my next video. So going towards this, you see the product is quite different. The product is quite different. There is a difference of product in case of molten sodium chloride and in case of solution of sodium chloride. The reason is, now in case of solution of sodium chloride, there is a water as well, and we get a certain ions from water as hydrogen ion and hydroxide ions. These ions also take part in the electrolysis, so the product may change entirely. The rules for the electrolysis in case of aqueous solution. Let me erase all these things. Should I erase all these things? Okay. The rules for the electrolysis of solution is like that. At the cathode, which has a negative charge, either a metal or a hydrogen will appear. Remember, at the cathode, either a metal will produce or a hydrogen will appear. Again, listen, at the cathode, either a metal will appear or a hydrogen will form. Now, the point is, how will we decide whether a metal will appear or will a hydrogen gas will appear? I have tried to explain this in this selective discharge list. This is hydrogen ions, and all those ions which are present above the hydrogen ions, they cannot reach earlier when we have to compare these ions with hydrogen ion. Again, listen, All those ions which are present at the top of hydrogen ions, that ions cannot reach earlier when we have to compare these ions with hydrogen ion. For example, I have to compare magnesium ions with hydrogen ions, and I have to decide which ion will reach earlier at cathode. Remember, hydrogen ion will reach earlier at cathode when I have to compare hydrogen ion with magnesium ion. When I have to compare hydrogen ion with calcium ion, hydrogen ion will reach at cathode earlier. And when I have to compare hydrogen ion with lead ion, remember hydrogen ion will reach at cathode earlier, because the ions which are present at the tops, they cannot reach earlier. The ions which are present at the bottom, they reach earlier. And when I have to compare copper ions with hydrogen ion, remember copper ion will reach at cathode earlier. When I have to compare silver ions with hydrogen ions, remember silver ions will reach at cathode earlier. So this is one way. The other way to predict that which ions will reach at cathode earlier is that list, which is mentioned here as well. This list is according to reactivity. This is potassium ion, sodium ion, calcium ion, magnesium ion, aluminum ion, zinc ion, iron ion, lead ion, and this is the hydrogen ion, this is the copper, and this is the silver. Increasing reactivity. It means reactivity is increasing from bottom to top. This is reactivity, don't get confused, guys. The other is selective discharge list. This is reactivity list. Reactivity of potassium is greater than the reactivity of silver and copper. The reactivity of sodium is greater than reactivity of calcium, magnesium, and aluminum, and the rest of these species, rest of these metals. So the ions which are present at the top of hydrogen, or the metal, or we can say the metals which are present at the top of hydrogen, that the ions of that metal will never reach electrode earlier. The ions of that metal will stay in solution, while the ions of that metals which are present below hydrogen, the ions of that metal will reach at electrode earlier. The ions of that metals, copper ions, silver ions, the ions of that metals will reach at electrode earlier as compared to hydrogen ions. The more reactive an element, the more it likes to exist as ions in the solution. They cannot discharge. So if a metal is more reactive than hydrogen, the ions stay in solution. The ions of that metal will stay in solution, and hydrogen gas will be bubble off. So the product at cathode will be hydrogen gas. But if the metal is less reactive than hydrogen, you see, like these two metals, they are less reactive than hydrogen, then the ions of that metal will reach earlier than hydrogen, and a product will be metal at cathode. At the anode, a non-metal other than hydrogen will appear. At the anode, a non-metal other than hydrogen will appear. If it is a concentrated solution of halide, such as chloride ion, bromide ion, iodide ion, then chlorine, bromine, or iodide ions will appear at anode. But if halide solution is dilute, there is no halide, only oxygen gas will be given off. And I will explain these rules with certain examples now. And now I'm going to end this session, because otherwise this video will be a slightly longer video, and this can produce disturbance for you guys. In my next video, I will explain again electrolysis of aqueous solution of ionic species with the different examples. All right, guys. Thank you so much for watching this video. Please do share this video with your classmates. Okay.